second to turn the page. But today we're going to talk about area and circumference. So something that you probably talked about back in elementary school, right? Maybe. And then we're going to add on this arc length and sector. So I've given you some notes today. This bottom part you guys don't see. Y'all just see this for right now. And sorry that that's printed so small, but you can print it a little bit bigger in that box if you want to. So the circumference is the perimeter of a circle. It's the distance around the circle. So when you hear circumference, it's the same thing as perimeter. The formula for circumference is 2 pi r, or you could say pi d, because remember the diameter equals twice the radius. So d is diameter, r is radius. And for area, the formula is pi r squared. Now, back when I was teaching at West Oaks, there was a teacher at Chestnut Grove who had a song for this. Y'all ready? We can even make some little hand motions if you want to. So if you have maybe a drink or something, you can hold it. If not, you can just make a fist with one hand and then take your finger. And this is how the song goes. Take your finger round the jar, circumference equals 2 pi r. For area, you multiply r squared times that number pi. The end. Isn't that cute? Oh, thank you. Okay, so let's try it again. Ready? Y'all sing it with me. Take your finger round the jar, circumference equals 2 pi r. For area, you multiply r squared times that number pi. Okay, everybody together. Take your finger round the jar, circumference equals 2 pi r. For area, you multiply r squared times that number pi. Good job, everyone. Fantastic. Okay, I always like songs because for me, it helps me memorize them and understand what's going on in the problem. Okay, so those are 2 formulas that you do need to memorize by next week if you don't have them memorized already, so songs help. All right, so let's do the first part of this worksheet down there at the bottom. We have some problems here that we're going to do together. So for these first 3, we're going to find the circumference and area of each circle. Notice it says leave your answer in terms of pi. What that means is you want to leave pi in your answer, but we also want to include units. So let's add that as an extra little info here, because I want to make sure that you have the correct units on this, because that will help you in the next 2 units that we do when we talk more about area of different shapes. Correct. So let's look at problem 27. In problem 27, what do we know? Good. We know the diameter is 20, which means the radius is 10. Good. I like to leave mine in terms of the radius, but then think about the formulas. So the first thing we have is circumference. Take your finger around the jar. Circumference equals 2 pi r. So you multiply 2 times r, which ends up giving you 20, which is the diameter. So this is 20 pi. So leave it in terms of pi means you don't actually multiply the pi in the problem. So again, we're doing 2 pi r, which is 10. So 2 times 10 makes 20. Tack on the pi with your answer. Now we need units. So remember, circumference is like perimeter. So if we add up all the sides, then it's just in centimeters. So it's 20 pi centimeters would be our circumference. Now, for area, you multiply r squared times that number pi. So what is r squared? 100, because 10 squared makes 100. So it's r squared times that number pi, and then put some units on it. If it's area, what are the units for area? Square, centimeters, or centimeters squared. So it's centimeters squared. Now, the reason it's centimeters squared is because we're timesing the radius by itself, right? Think about what we did when we did x times x. What's x times x? x squared. So when we do centimeters times centimeters, it's centimeters squared. That's where the squared comes from. Does it mean that I square the 100 or the pi? No, it's just the centimeter part that I'm squaring. Okay, so let's look at our next problem. What are we given in problem 28? The radius. So our radius is 3. So take your finger around the jar. Circumference equals 2 pi r. So 2 times 3 is 6. Multiply that by pi and then put units on it. So the circumference is 6 pi feet. For area, you multiply r squared. So what's r squared? 9. And then we put what with it? Pi and units, feet squared. Good. So if we double that number, if we double our radius, we get our circumference. And if we square our radius, we get our area. Okay, so let's look about what do we know in problem 29. Well, we know the radius is 4.2. So to get the circumference, we need to do what with the radius? Times it by 2. So we double 4.2, we get 8.4. What needs to go with it? And units. Good. Now, what do we do with the radius to get the area? Square it. Yep, not square root, but square it. We want to make it bigger. So in your calculator, we got 4.2 squared, which gives us, and we're going to leave that as a decimal, but we're going to tack on pi, and then units would be, that's it. So remember, circumference is 2 pi r. Take your finger around the jar. And then for area, r squared times that number pi. Okay. All right, so let's look at our next set of problems. Now, our next set, we are given the circumference, and we need to find the radius. So we're kind of going backwards of what we had. Now, one thing that you can do is you can set this equal to the formula. So if you have the circumference, the formula is 2 pi r, right? Now, both sides have what? They both have pi. So we can actually divide both sides by pi and get rid of it. So 16 equals 2r. So r must be 8. Now, this didn't put any units with it, so we're just put 8 units, whatever those units could be. We don't put pi with a radius. We didn't have pi with those radiuses up there, right? So don't put pi with this. Pi just goes with circumference and area. So since they're on both sides, they can cancel out and just go away. Now let's do the same thing with our next problem. We're given the area. What's the equation for area? Pi r squared. Now notice again, pi is on both sides, so we can cancel it out. Yep. So 81 equals r squared. So r is 9. So our radius would be 9 units. What's a shortcut with both of these problems? Yep, you divide by 2 or you take a square root. And basically the pi's just cancel out, right? They go away for this. And you could double check it, right? If the radius is 9, 9 squared is 81, tack on the pi. If the radius is 8, we times it by 2 and tack on the pi. All right, now this one's a little bit different. It says, what is the diameter if the circumference is 37.68? So this is our circumference is 37.68. Correct. So let's go ahead and set it up with a formula, and then you're exactly right. That's what we will do. If we set this up with a formula, what's the formula for circumference? 2 pi r. We can use the same formula each time, or we could use our other formula. We'll talk about that in a minute, though. So 2 pi r equals 37.68. And now notice it said use the estimate for pi, which is 3.14. We don't always use that estimate, but if it tells us to use it, you can plug that in for pi, and then you can use that number if you would like. So if we double 3.14, we get 6.28 times r equals 37.68. And then you would just divide, right? So r would equal just 6. That's nice. That's probably why they told us to use 3.14. It gives us a nice pretty whole number. But the question asks for the what? The diameter. So the diameter would be, 12. Just double it. Make that diameter. Don't square it. So diameter is 12 units. So you could set up that formula, but Xavier said another way, because Xavier, what's the formula for circumference as well? Pi d equals 37.68, right? Now, if we replace pi with 3.14, we have 3.14d equals 37.68. So D would equal, take 37.68 divided by 3.14, 12. So an alternate way is to use pi D, if you remember it, that it's also circumference. But if not, use 2 pi r. It works out. All right, let's turn the page. We got a little word problem to do here. I hope that you like my illustrations. I don't draw things anymore. One time I tried to draw a lighthouse. It was not pretty. Okay, so this one says the wheel of an adult's bicycle has a diameter of 26 inches. The wheel of a child's bicycle has a diameter of 18 inches. To the nearest tenth, how much farther does the larger bicycle wheel travel in one revolution than the smaller bicycle wheel? So let's start with that first sentence. It's telling us the wheel of the adult's bike has a diameter of 26. So I'm going to write that underneath that picture. Here's my adult bicycle, old grandpa driving his bike. Okay, and then the child's bicycle has a diameter of 18 inches. So this one, diameter 18 inches. To the nearest inch, how much further does the larger bicycle travel in one revolution? What is it talking about a revolution? How far it goes in one loop, which is asking us for the what? Circumference, right? Take your finger around the jar. That's what I think about. We're going around. So one revolution is asking us for one circumference. So what we need to do is find the circumference of each of these bikes, and then we can figure out which one goes further. So if we want to use the formula that we talked about in the last problem, circumference equals pi d. So our circumference for the adult bike would be 26 pi, and then for the kid's bike would be, bless you, 18 pi. Since we already know the diameter, we just plug pi with it. But the question says, to the nearest inch, how much further does it travel? So what do we need to do with our two circumferences? Subtract them. So it's 26 pi minus 18 pi, which would give us how much? Now think about just those numbers. What's 26 minus 18? 8 pi. Now 8 pi is not to the nearest inch, so let's grab our calculators. And guess what we have on our calculator? A pi button. So if it doesn't tell you what to use for pi, use the pi button. Where's the pi button located? Second, and that caret key to make that exponent. Good. So 8 pi is about 25.13. Now, it told us what to round to. What did we need to round to? The nearest inch. So it's about how many inches? 25 inches. Now, I may ask you for an exact number, so an exact number would be 8 pi inches, but word problems might ask you to just round, so 25 inches would be fine. If it doesn't ask you to round, it might say leave it in terms of pi, or you can round to 2 decimal places. All right, let's look at something a little bit different, triangles, because we've seen a lot of triangles pop up in circles, right? Yeah. So one thing that we need to review is the area of a triangle. So I gave the formula here. Area equals 1/2 base times height. Some of you might have written it like this in middle school. Base times height divided by 2. Either way, it means the same thing, right? Now, the base of a triangle is always what it's sitting on. So imagine it's sitting somewhere. And the height is the overall height from the ground to the peak. And it is always a vertical distance, kind of like altitude. You've probably heard altitude when you talked about a plane, right? Your altitude is not a diagonal height, but it's the vertical, straight up and down height from the bottom all the way to the top. So looking at this first triangle, what is the height? Good. This is our height. Now, where that altitude makes a right angle with the third side is your base. So my base is going to be 11. So let's find the area of this triangle. Area equals 1/2 base 11 times the height 13.4. And then I would just use my handy dandy calculator to figure that out. So it's 1/2 base times height. I like to use parentheses, but it really doesn't matter. If you just put the times symbol between, it should work out. So the area of this triangle is good. 73.7. And we're talking about area, so it would be units squared. So 73.7 units squared. Okay, let's look at this second picture. What is our... Now, this one looks a little confusing, but this shaded part right here, I don't know if I shaded it on yours. No, I didn't. This part right here that's colored in, this is your actual triangle that you're looking at. So this line over here, this dotted line, is your height. This is your altitude or height. And so what's the base of my triangle? It is 4. You're right. So my equation is 1/2 times base times height. And you can calculate that. I hear y'all calculating. 35.4. And don't forget to put units squared. Very good. All right, let's flip the page. We're moving right along. So that was a little side note about area of triangles. So now we're going to move to our next part, which I don't have on this slide because I moved it back to the first slide. That's this information here at the bottom about arc lengths and sectors. So an arc length, an arc is a part of the outside of the triangle or circle. No more triangles. We're talking about circles again. Circles. We have talked about how to find the measure of that arc, right? If we have angles that are at the center, this is just a good review. So we have we have a triangle here. If the angle is at the center, let's say this angle is 90 degrees, then what's the measure of this arc? 90 degrees. If that angle moves to be an inscribed angle, let's say this angle is 45 degrees, what's the measure of this arc? 90 degrees. So if the vertex is at the center, it's the same. If the vertex is on the circle, it's double to get that arc. Good. So we have a certain equation here to find the measure of an arc. So I kind of highlighted in blue, but it's kind of hard to see. But we want to find the length of this arc from here to here. So the length of any arc is a proportion of the circumference. It's part of the circumference, right? To get that part, it's the measure of the arc over 360. That gives you the proportion or the fraction. And then you times it by the actual circumference. So arc length and circumference go together. The only thing that you need to do is multiply by that proportion. Now, a sector is a piece of the area. It's kind of like one slice of pie. I want to figure out how much pie I'm eating, so it's just one slice of that pie. And for that, you use your area formula, because the area of a circle is pi r squared, but then you still multiply it by this proportion. So that proportion is part of the area. And that's how arc length and sector work. So let's do some examples, if I can get back to them. Here we go. Now, I know you cannot see these in red, but what you can do is you can make them darker on your paper. So we're trying to find this arc length in this picture, this arc in this picture, and then this large arc in this picture. So make those a little bit more bold, because I know they don't show up quite as good on the black and white copies that I print. So all of these are finding the outside of the circle. So that would be part of the circumference. So in order to do all of these, we're going to do the measure of the arc over 360 times the circumference. What's the equation for circumference? 2 pi r. So in this first equation or first circle, we already know the measure of that arc. The measure of that arc is 45. So we're going to do 45 over 360 times 2 pi r. Well, what's r? 14. Now, there are a couple ways that you can simplify this. You could type this first fraction in and simplify it to be a little bit smaller. You could go ahead and multiply the 2 and 14, and then you can multiply it together. Or, since we have calculators, just put it all in together. 45 over 360 times 2. Now, don't put the pi in because we want to leave it in terms of pi, but it's 2 pi r, and r for that problem was 14. So, our arc length would be 3.5 pi. Good. Centimeters. Yep, exactly right. Since this is part of the circumference, it's just centimeters. All right, let's look at problem 35. So the first thing that we need is the measure of this arc here that's bold or in red. What's the measure of that arc? How do you know it's 120? That's right. If this is 60, this has to be 120, because what is this right here? The diameter. So my diameter splits my circle in half. So that missing arc has to be 120. So when we start out this problem, we have 120 over 360 times 2 pi r. Now what would go in the place of r though? 12. Good. Because we're given the diameter, so the radius is half. And then just use your handy dandy calculators and let's multiply that together. So 120 divided by 360 times 2 times 12 is 8. 8 what? 8 pi feet. Very good. Don't forget the pi and don't forget the units. Okay, last one we have here is problem 36. So first off, we need that arc measurement. Exactly. If this is 90, then this is 90. So this arc would be 360 minus 90, which is 270. So when I set up this problem, I have 270 over 360 times 2 pi r. What's going in the place of r? 18. That's right, because this is our radius. So 270 over 360 times 2 times 18 is 27. Don't forget the pi and meters. Muy bien, la clase. About all the Spanish I know. I used to walk in every day to Spanish class, and our teacher would go, "Hola, la clase," and we'd go, "Hola, señora Nergart," and then she would say, "How are you doing? What is that?" No, I forgot. No. ¿Cómo estás? And we'd say, "Muy bien, gracias." ¿Y tú? And she'd go, "Así, así." Every day. Every day. Every day. All right, here we go. Let's find the area of a sector. So, similar formula, except instead of using, we use pi r squared. Good. So, it is the measure of the arc over 360 times pi r squared. Choose some different colors. Okay. So what's the measure of our arc? Because we can see the shaded part. So the measure of that shaded arc is 45 over 360 times pi. And radius is 18. So it would be times radius squared or 18 squared. So just to show that, plugging in the calculator, we have 45 over 360 times 18 squared. Type in everything except the pi. So my answer is 40.5. And we tack on the pi, and then don't forget units. Now in this case it would be yards squared, because we're talking about area. Area always has square units, because we're doing 18 yards times 18 yards. So that works out. Okay, problem 8. We need the measure of the arc. What's the measure of the arc? 90 degrees. If the central angle is 90, the arc is 90. Do we have the radius? By golly, yes. So let's just plug it all in. So we have 90 over times pi r squared. So pi 16 squared. So 90 over 360 times 16 squared. 64 pi, good, centimeters squared. Love it. Y'all are doing great. Oh, this last one might be tricky. All right, we know that this angle here is 45 degrees. So what's the measure of this arc? Yep, this one is also 45. So the measure of the big arc that we need is 315. 15. You're right. 315. So if I wanted to set up this problem, I would write times pi 8 squared. Good, because this is our diameter, so our radius is 8. 315 over 360 times 8 squared is no tricking you guys. You're all math geniuses today. I know, I love it. All right. All right, the last two problems are definitely the hardest two that we will do today, but as you can tell, if you know your formulas, they should not be hard. And if my board changes, that would be even better. But it wants to take a hiatus today. So while it's taking a little break, let's just remember, what is the area equation? Just area. Pi r squared. Okay, what is the sector equation? Good. So sector and area go together. Okay, so remember that. Area, sector, together. Okay, then we have circumference equals 2 pi r, or what's the other equation? Pi d. And what goes with circumference? Arc length. And so what's the equation for arc length? Very good. Okay, so let's do our problem here. What is the diameter if the area of the sector is 7/2 pi feet squared and the arc measurement is 210? So it's giving us some information, and right here it gives us the area of the sector. So if we can set up that equation, then we can solve. So if it's a sector, you guys just told me the equation was measure of the arc times pi r squared. So we are going to set up an equation with that in order for us to solve. So we know the area of the sector is 7/2 pi, and we also know the arc measurement is 210. So 210 is going to go there for that arc measurement, and then it's going to multiply by pi r squared. Correct. Both pi's are multiplying on each side, so if we divided both sides by pi, those pi's would go away. So we get 7/2 equals 210 over 360 times r squared. Do what? You could. If you wanted to, you could multiply both sides by a fraction. That fraction would have to be the reciprocal, which means that you would have to flip it. Or you could just divide by that fraction, right? Either way would work. Just be careful because these are fractions, so they need to be put in parentheses. So you can divide both sides by 210 over 360. That will work. You could also multiply by 360 and then divide by 210, whichever way. But just make sure that you use parentheses, and make sure that you divide the correct way. 7 over 2 is on the left side. We're dividing by the 210 over 360, so we get 6. So r squared equals 6. Then we have to do what? R equals not 3. Don't divide it by 2, but what do we have to do with it? Square root it. Yep, so we're going to square root both sides. So r would equal square root of 6. Now, be careful because if we read back up here in the problem, it doesn't ask us for r, it asks us for diameter. So how do I get diameter? Yep, so it's 2 times r, so it's 2 times square root of 6, or just 2 square root of 6. Don't forget, you could put units on this. What are the units in the problem? Feet. It gave us the area in feet squared, so our diameter would be in feet. Now, if it asked us to round that number, then we could round to a couple of decimal places and go from there. But that's how you want to do a problem like that. Now, what if pi was not on either side? Could I cancel out these pi's then? No. So if that happened, you might get down here and still have a pi at this r squared equals 6. So you would divide by pi and then square root. And if you have to divide by pi, it's not going to make it into a fraction or a nice pretty decimal because pi is an irrational number. So just round to 2 decimal places. Okay? All right, last problem. Maybe. Now, when we do this last problem, for homework, you're going to have a worksheet that you need to do, and so I think you guys will have plenty of time to probably finish that before you leave, and if you do, just show it to me, and I will check it off before you leave, so that way you can take it home and study, because as soon as we get back from fall break, we have those 2 days that we come back. On Monday, we're reviewing, and on Tuesday, we are testing. Yes. So you're going to have to spend some time over fall break just reviewing things about circles, because I don't want your first test of the quarter to be down here because you didn't review, right? So each day, just do a little bit each day to just kind of remind yourself. And I'm going to give you a review packet to do that's going to count as 2 homework grades today. And so it will be due on test day, though, so you have a whole week to do it. But somebody in here came to tutoring yesterday, and I went ahead and gave them the packet, and they started working on it, and they already got a third of the way through just in the 30 minutes that they were here for tutoring. So anyway, let's do our last problem since it finally decided to show up. This one says, find the area of each shaded segment. So if you notice on here, this is kind of like a pizza. Somebody took a slice of the pizza, they ate the pizza, and they left the crust. That's kind of what this looks like to me, right? So that's what you want to think about when you set up this problem, because the first thing that we want to do with this is think about this as being your pizza right here. If I were to shade that in, that's a what? Part of it is a right triangle, but if you throw on that crust, it starts with an S that we just talked about. It's a sector. So what you have to do first when you start off these problems is you're first going to find the area of the sector, and then you're going to subtract off that area of that right triangle. So now what's the equation for area of a sector? And then what's the area of a triangle? Good. So first off, what we're going to do is calculate the area of the sector, then we'll calculate the area of a triangle, and then we'll keep simplifying. I know the problem says round to the nearest tenth, but I also want us to get the exact answer, and then we're round. So what's the measure of our arc? 90. That's right. If this is 90 here, then this arc is 90 degrees. So 90 over 360 times pi. Now what's r? 8. 8 squared. So let's calculate that. Let's just use our calculators. 90 over 360 times 8 squared is 16 pi. Okay, so now we're going to minus the area of that triangle. So my triangle is 1/2 base times height. Now it's pretty easy to see the base. The base of this triangle is 8. But what's the height? It is also 8. Why is it also 8? That's right. This is our radius, but what's this right here? It's another radius, and our radiuses, or radii, are the same. So not only is this a right triangle, but it's an isosceles right triangle because those parts are the same. So the base and the height are both 8. Very good. So what's 1/2 of 8 times 8? 32. So if we were asking for an exact answer, this would be our exact answer. We'd put some units on it. It's 16 pi minus 32 feet squared. But this problem did ask us to round to the nearest tenth. So let's go to our calculator. It didn't give us pi, so we use our pi button. So remember second and the caret key. So 16 pi minus 32. Was about 18.27. It did say tenth, so tenth is usually the first decimal place, so 18.3. I like 2 decimal places, but I just copied it from a book. So 18.3 feet squared. Okay, let me tell you about all of your work for today, and I do want to show you this worksheet. So tonight's homework is a worksheet, and that is not it. I probably should pull it up this way. Look at all the stuff we've done so far, guys. Look at all that. We've done all that. Doo-doo-doo. There it is. Okay. So this is what the worksheet looks like that you're going to be doing tonight. But when you see this big table, each column is a problem, okay? So on this first row here, I'm giving you the radius and then find the circumference in the area. Then if I give you the circumference, probably easiest to find the radius and then find the area. If I give you the area, find the radius, and then you can find the circumference. Then you have some word problems, so do those. And then you have area of a sector and arc length, and then some other problems down here. It won't take quite as long as what it seems because these go pretty fast. I mean, we just did 4 pages of notes in under 30 minutes. Then also for homework, because of fall break, I want you guys to do this code breaker activity, and so I'm going to give it to you. It looks like this right here. So each page is basically a set of problems that you will have. Now the first one is just naming segments, but follow the directions. They usually start here, but they might have some more on the other pages to help you out. Some of this says cut and paste, but don't cut and paste because I made it two-sided. So if you cut and paste, you're going to cut off the other problems that are on the back. So I tried to simplify it. However, if you go on to Canvas, I printed just the full page documents. So I guess if you really did want to cut and paste, you could look at them as a full page document here. So before you leave, you might want to just read through. But basically, you're solving every problem. And you want to make sure there are some problems that you need to show work for, like if they say solve for X and things like that. I tried to write show work on these if I needed you to show work, so you might have a piece of notebook paper that you're going to have to attach to this when you get done. Just make sure you label it because there are 6 escape rooms labeled A, B, C, D, E, and F. And each escape room has a special little code that you can use. And I'm going to give you 5 points for each code that you get correct. So this homework assignment, you could get up to 130 points because there are 6 codes. And if I give you 5 points each, if you get the codes right, that's 30 points. Does that make sense? Okay, so that's a lot of extra credit for homework. So this will count as 2 homework grades, so you could get up to 130 on each of those homework grades. But you got to be careful with the code. Now, there's one code, which I believe it is B. Yes, B says down here when you're doing the code break, my board's pausing again, that you need to see me for the decoder wheel, because that's going to help like put the final answer here, but you can do all the work until that final answer. And then I've got a decoder wheel that you can use to adjust it to get the answer for that question. But everything else you should be able to do. So it's not due until test day, but again, work on it over the break so that way you're ready for the test. Okay? Any questions about what you need to do? Okay, and also don't forget, if you have some extra time, you can work on your roller coaster artwork layout project as well. Now, when we come back on Monday, we are going to do our review on Monday, and this quiz is that's listed here on Canvas. Don't do that yet. We're going to save that for Monday, okay? And then we're also going to talk about our roller coasters a little bit more on Monday. So do not do this, okay? Do this and this. Do your worksheets over break.